The window for gaining unfair learning compounding is narrower than marketing headlines suggest. We unpack the operational lever that accelerates it. Welcome to AI on AI, where we dissect the next generation of agentic systems. Today, we're unpacking a draft-centric test-time diffusion approach for deep research agents that claims big gains on long-form reports and multi-hop search tasks. Joining me are a technical research scientist focused on retrieval-augmented generation, a business strategist leading AI adoption at enterprise scale, an enterprise architect for agent frameworks, a reinforcement learning and evaluation specialist, and a product leader in regulated industries.
Thanks for having me. Here's the elevator pitch. Instead of a linear plan, search, write pipeline, this approach treats the report like a noisy image that's denoised over multiple steps. The twist is that each denoising step is grounded by fresh retrieval, so the draft both guides what to search next and is refined by what we just found, forming a closed loop that mirrors human research. Plan, draft, search, revise, repeat.
From a strategy perspective, that draft as controller is the big shift. Most public agents bolt on parallel search or per-section research, but they lose global coherence. A living draft keeps the North Star intact and reduces information loss across long trajectories, which translates into fewer detours and more executive-ready narratives.
Architecturally, think of 3 stages. Stage 1 produces a structured research plan. Stage 2 loops across search question generation and an answer synthesizer that acts like a RAG system but stores distilled answers instead of raw docs. Stage 3 fuses the plan and all QA pairs into the final report. And now add 2 test time algorithms, component-wise self-evolution to upgrade each unit agent, and report-level denoising with retrieval to update the draft continuously.
Let me go deep on the denoising loop, because the analogy to a Bayesian filter is not just cute, it's operational. Treat the evolving draft as the prior, retrieval as the measurement, and the revision step as the posterior update. The algorithm iterates, generate next question conditioned on the prior draft, retrieve and synthesize, then revise the draft. A stop condition triggers when coverage or quality thresholds are met, so it's an anytime algorithm with graceful early exits.
And the self-evolution layer is like an evolutionary tournament around each component. You sample diverse variants by varying temperature, sampling strategies, or prompting, score them with an LLM as a judge on helpfulness and comprehensiveness, deliver textual critiques as fitness feedback, revise the candidates, loop a few times, then cross over to merge the best content. The net effect is richer, question diversity, and answer granularity that feeds the denoiser better fuel.
So, a dual-loop system. Outer loop denoising with retrieval for the report, inner loop self-evolution for unit agents. Great. Can we talk about why the usual linear or per-section methods stall?
Linear agents suffer myopic search where early paths lock in assumptions. Per-section research loses cross-section dependencies, like confusing market drivers with regulatory constraints because the signal is split. The draft-centric loop keeps a single, globally consistent context that gets sharpened step by step, which reduces contradictions and duplicate work.
There's also state hygiene. Saving distilled answers, not raw pages, gives you structured high-signal breadcrumbs. Later steps operate on curated facts, so the denoiser can reason over deltas instead of sifting through noise, which matters when you hit 10 to 20 hops.
Right? And from a business lens, those hops are where value accumulates. In a global consumer brand case, the team used a draft-centric loop for a market entry report and saw time to insight drop by roughly a third, because the agent stopped relearning the same things across sections and instead prioritized the next uncertainty that moved the decision.
Technically, the novelty gating is critical. After each revision, the next question generator is asked to maximize coverage of missing draft slots and penalize overlaps. Call it an adjacent novelty heuristic. So you keep discovering new facts while maintaining coherence. This mirrors exploration exploitation in RL without a heavy training loop.
I want to challenge a common intuition. People think the diffusion metaphor is just branding, but the empirical curves show early steps contribute disproportionately to final quality when the draft is updated in sync with retrieval. If you postpone integration until the end, you burn compute searching blind, and you miss compounding effects.
Let's get specific. Walk me through a single iteration and the control signals that make it work.
Step by step. 1. The draft identifies gaps, say competitive pricing tiers missing in APAC. 2. The question generator uses the plan, the draft, and QA history to craft a targeted query. The answer synthesizer retrieves top sources and returns a concise attributed answer with confidence notes. 4. The denoiser revises the draft, additions, clarifications, or corrections. 5. A meta check decides if we exit based on coverage metrics and diminishing novelty. The magic is the draft's top-down influence on what to search next.
And under the hood, you can instrument 3 signals: draft coverage, percentage of plan sections with evidence; novelty, new key points versus known set; and draft stability, how much sections change per step. If novelty drops below a threshold and stability rises, the loop exits early, keeping latency predictable.
One caution: Goodhart's law bites if you optimize only for the judge's scores. That's why they calibrate the LLM as a judge to human raters with side-by-side preference prompts, then keep the judge's rubric anchored to both helpfulness and comprehensiveness. You also rotate judge prompts to reduce overfitting to a single critic voice.
On outcomes, a consulting team piloting this approach for a turnaround strategy report saw better coverage depth, fewer missing tables and corroborated claims, and stakeholders reported higher trust because citations were consistently used to revise claims rather than append them at the end. That last shift is subtle, but it changes perception of rigor. You're teeing us up for the evaluation. How did the side-by-side framework and calibration actually work, and what did it reveal?
The evaluators compare pairs of reports along helpfulness, intent match, fluency, accuracy, tone, and comprehensiveness, missing key info. The team aligned the judge to human preferences by rating a few hundred pairs and picking the judge configuration with best agreement. The result was clear. The draft diffusion agent won the majority of head-to-heads on long-form tasks.
On multi-hop short answers, correctness also improved, partly because the answer synthesizer is RAG-like and trained to produce a single clean answer after retrieval, rather than relying on the report generator to fish out the final nugget. That separation of concerns tightens the chain.
And the Pareto analysis matters for operations. Plotting win rate against log latency shows the steepest slope when adding self-evolution and denoising, meaning each extra second buys more quality than competing designs. For platform teams, that's how you justify compute budgets with clear frontier gains.
Speaking of budgets, enterprises will ask, can we dial the knob between accuracy and latency? Is this adaptable?
Yes. Set a max step cap, use early exit thresholds, and implement a 2-phase schedule. Perform 3-5 fast steps for broad coverage, then allocate remaining steps to the most uncertain section. If you attach a decision-aware gating, say finances or safety-critical sections get more steps, you align compute with risk.
And that alignment shows up in benefits. A regional bank used a risk-weighted schedule for compliance updates, allocating extra denoising steps to new regulations. This cut revision cycles by about a quarter and improved internal audit acceptance on first pass. The novelty is linking compute to governance hotspots, not just to document length.
There's a deceptively powerful baseline embedded here. By saving answers as structured atomics, claim, evidence, source, confidence, you get provenance baked in. The denoiser can then verify and cross-link, which reduces hallucinations and makes audits smoother.
Let's hit a contrarian angle. What if the diffusion metaphor isn't the true cause? Could we get similar gains with a hierarchical planner or aggressive per-section loops?
I'll be the contrarian. My claim is that the biggest boost isn't diffusion per se, but draft as controller. Any architecture that maintains a single global scaffold, continuously updated, will outperform per-section agents. The denoising loop is one way to implement that control policy effectively, but the principle is centralized global context, not the metaphor.
I agree on the principle, but the denoising algorithm couples the control policy with targeted retrieval in a way hierarchical planners often don't. Planners tend to schedule tasks but don't update the whole draft at each step. That revision is what allows new evidence to cascade through the outline, so conflicts get resolved earlier.
Also, the empirical novelty curves show question diversity jumps when revisions feed into the next query. Without that feedback, planners repeat near duplicates. Classic bandit exploitation too early. So yes, controller is key, but the specific loop matters.
From the boardroom, the nuance is academic. What matters is risk and throughput. A global draft that refines continuously reduces rework across teams and vendors. We don't care if you call it diffusion or dynamic scaffolding, as long as governance and measurable outcomes are strong. Let's ground this in a technical deep dive on self-evolution. What design choices made it robust rather than a fancy best of N?
3 choices. 1. Diverse initialization. Sample multiple candidates via temperature and top K variations plus prompt perturbations to widen the search space. 2. LLM as judge with textual critique, not just scalar scores, so each candidate gets actionable guidance. 3. Crossover merging. Final output blends non-overlapping contributions to avoid winner-takes-all mode collapse. That crossover step is underappreciated and boosts recall.
And we can treat it as a light multi-objective optimization, balance helpfulness and comprehensiveness rather than collapsing to one metric. Candidates that are concise but incomplete get penalized in the merge unless balanced by a complementary variant. This reduces systematic omissions.
Implementation note: run evolution in parallel per stage to keep latency bounded, e.g., 2 rounds of critique revision are often enough. After that, marginal gains taper. You can adaptively stop based on variance of fitness scores. When variants converge, call merge early.
There's a pitfall: overfitting to the judge. Mitigation includes rotating evaluation prompts, adding heuristic checks for citation density and contradiction flags, and occasionally injecting human spot checks on high-risk tasks. Think of it as guardrails around Goodhart.
Business case time. Give us 2 or 3 domain-specific examples with concrete impact patterns. Example 1. Biotech competitive intelligence. Teams need a 20-30-page landscape with mechanisms of action, trial timelines, safety signals. The agent's denoising loop prioritized missing safety signals early, then backfilled trial endpoints. Internal reviewers saw fewer post-hoc corrections, and overall cycle time fell by around 30%, with a measurable uptick in perceived rigor.
Example 2. Manufacturing procurement. Multi-hop vendor assessments often sprawl. Using draft-guided retrieval, the agent built a normalized scoring sheet from spec sheets and certifications, catching conflicts between marketing brochures and audit PDFs. This trimmed decision lead time by roughly a quarter and increased consistency across plants.
Example 3. Technology due diligence. The agent used self-evolution to generate divergent risk questions, security posture, data residency, upgrade cadence. Then the denoiser harmonized the narrative. The outcome was fewer follow-up calls and a clearer executive summary that aligned engineering and legal, which is rare in one pass.
Let's talk emerging markets, lower compute budgets, patchy connectivity, multilingual sources. Does this approach still hold?
Absolutely, but you need compute-aware policies, a thin diffusion mode with fewer steps, and an aggressive novelty threshold, on-device caching of retrieved snippets, and bilingual retrieval where the draft asks for local language sources to avoid bias. Early exit is your friend when bandwidth is constrained.
And a counterfactual that matters. In markets with weak web coverage, the agent should prioritize enterprise intranets and regulatory bulletins. Self-evolution can diversify search angles across those silos, while the denoiser maintains a coherent story. Think inside-out RAG rather than web-first.
Strategically, this changes knowledge governance. Local teams can contribute curated corpora and tune the plan templates to regional realities. The central platform still enforces evaluation and provenance. The third-order effect is talent uplift. Junior analysts deliver senior-level structure because the agent scaffolds their thinking. Evaluation bias, LLM as judge has skeptics. What made their calibration credible? And how do we keep it honest in production?
Two things: a side-by-side human study that aligns the judge rubric to actual human preferences, and a domain-agnostic rubric for helpfulness and comprehensiveness. Then in production, you sample a small percentage of runs for human adjudication and track drift. If judge-humans divergence widens, you retune.
Also, don't let the generator see the exact judge prompt. Keep a hidden evaluation schema. Otherwise, you'll get report doping, where the agent pads sections to score points. A rotating committee of judges, different models, different prompts, blunts that failure mode.
For enterprises, pipe evaluation signals into dashboards by section, accuracy on regulatory claims, coverage of critical risks, citation redundancy. You'll spot systemic issues, like over-indexing on press releases, before they become compliance problems.
Latency and cost. How do teams keep this efficient at scale without throwing more hardware at it?
A few levers: cache and reuse QA pairs across similar tasks, deduplicate retrieval via shingling, use a passage-level index to avoid refetching entire documents, and profile novelty. If 2 consecutive steps add under, say, 5% new key points, auto-stop. For scheduled reports, warm start with prior drafts and only denoise the delta.
And treat compute as a portfolio. High-risk decisions get full diffusion, routine briefings run in sprint mode. We saw an operations team balance those tiers and maintain service-level targets while improving average quality. I want an analogy that sticks. What makes this differ from classic RAG with a better planner?
Classic RAG is like cooking a la carte. Each query returns ingredients you combine once. Diffusion with retrieval is a slow simmer stew. You taste, adjust seasoning, add ingredients, taste again. The evolving draft is your palate, guiding what to add next and how to rebalance the whole dish.
Or, if you prefer signal processing, every step is a predict update cycle. The prior is the draft, the measurement is retrieved evidence, the posterior is the revised draft. Iterate until uncertainty falls below a threshold. Same mathematics, different domain.
Governance and safety. How does this approach reduce hallucinations and provide auditability?
By storing structured answers with source links and confidence, then revising the draft using only supported claims. When a claim lacks corroboration, it's flagged or softened. In audits, you can replay the trajectory, every question, answer, and revision, like a versioned ledger.
Add a contradiction detector. If new evidence conflicts with the draft, trigger a micro-debate among variants during self-evolution. The merge step then forces explicit resolution or dual-view presentation. Better to show uncertainty than mask it.
For risk officers, that forced humility is gold. Decisions don't hinge on brittle assertions but on transparent trade-offs with citations. Let's address integration. What's the minimal stack an enterprise needs to pilot this?
You need 1. A capable LLM, 2. A retrieval layer with web and internal indices, 3. An orchestrator to run the 3 stages and the 2 test time loops, 4. An evaluation harness for side-by-side scoring. Start with 10 to 12 denoising steps, 2 self-evolution iterations per stage, and a conservative novelty threshold. Tune from there.
And design your agent state schema from day one. Plan slots, QA entries with claims and evidence, draft revisions with diffs, and evaluation logs. State discipline is what enables reproducibility and safe rollback.
Where does this go next? What's on the horizon technically and in strategy?
Technically, multimodal retrieval for charts and tables, lightweight browsing tools to anchor quotes, and code execution hooks for data validation. Plus RL tuning to learn better question policies from preferences, closing the loop between evaluation and behavior.
Strategy-wise, domain-specific plan templates and judge rubrics for healthcare, finance, infra, enterprise search adapters to private knowledge, and a co-pilot mode where humans can inject interventions mid-loop. Zoom into that anomaly, which the agent then amplifies across the draft.
Expect second-order market shifts. SEO content will evolve to target agent retrieval rather than human skimming. Regulators will ask for agent trajectories as evidence. and vendors with clean, structured documentation will see disproportionate inclusion in enterprise reports. Documentation becomes a growth lever. Before we wrap, one more contrarian thought. What's everyone overlooking?
Everyone chases efficiency, but the bottleneck is often concept drift in fast-moving domains. The diffusion loop helps because it updates the whole narrative quickly when a single fact changes. Think of it as rapid narrative rebalancing. Without that, teams suffer stale synthesis.
I'll add a system view. The real risk is silent redundancy. Agents repeatedly rediscover the same fact. Novelty-aware denoising plus answer caching is the antidote. It's not flashy, but it saves more compute than model compression in many cases.
And a caution, don't over-rotate to judge scores. Bake and hold out human reviews on critical sections. As someone said, in God we trust, all others bring diversified evaluators.
Finally, for emerging markets, prioritize offline-first indices and translation-aware retrieval, then gradually grow the step budget as infrastructure allows. Excellent orchestration beats brute force compute.
Let's land the plane with takeaways. 2 sentences each. What should business and tech leaders do Monday morning? Business leaders. Pilot a draft-centric research agent on one high-impact report, enforce provenance, and compare head-to-head with your current process. If you see fewer revision cycles and clearer decisions, scale with tiered compute policies.
Technical leaders, implement the 3-stage backbone, add self-evolution with critique and merge, then layer denoising with retrieval, instrument coverage, novelty, and stability to drive early exits and keep the Pareto frontier on your side.
Platform teams. Standardize the agent state schema and caching. Wire an evaluation harness with side-by-side comparisons and drift monitoring, and use risk-aware step schedules.
Researchers, explore adaptive question policies, bandit style or RL, to learn which draft gaps deliver the highest marginal value. Aim for better question economics, not just more steps.
Product leaders, build domain templates and governance hooks first. A well-scoped template with strong evaluation beats a fancy demo every time.
That's a wrap. Drafts that think, retrieval that grounds, and evaluation that keeps us honest. Thanks to our experts and to you for tuning in. And as always, stay curious and keep iterating. Before we sign off, let's stitch the thread end to end. Today we walked from problem to pattern to performance. Traditional deep research agents plateau because they search and synthesize linearly, while a draft-centric, test-time diffusion loop treats the report as a living artifact that repeatedly guides retrieval and is refined by it. Add component-wise self-evolution to upgrade each unit agent, and you get a dual-loop system that's coherent, timely, and measurably stronger on long-form and multi-hop tasks.
Technically, the crux is a predict-update cycle. Draft as prior, retrieval as measurement, revision as posterior, instrumented by 3 signals: coverage, planned sections with evidence, novelty, new key points discovered, and stability, how much sections change per step. Early compounding is real when the draft updates in sync with retrieval, and the self-evolution tournament, diverse initialization, critique-based revision, and crossover merge supplies richer questions and higher precision answers for the denoiser to ingest.
Architecturally, it's a disciplined 3-stage backbone. Plan generation, iterative QA with RAG-like synthesis that saves structured claims rather than raw pages, then final fusion. Plus an orchestrator that keeps a clean state ledger, plan slots, QA atomics with provenance, draft diffs, evaluation logs. Caching and novelty-aware dedup make 10 to 20 hops practical, and risk-weighted step schedules push compute to the sections that matter most.
On evaluation, the side-by-side framework calibrates an LLM as a judge to human preferences across helpfulness and comprehensiveness, which helps avoid Goodhart traps. Rotate critic prompts and add heuristic checks, citation density, contradiction flags, to keep it honest. Then, looking forward, learn adaptive question policies with bandit or RL methods to improve question economics, i.e., which gap yields the highest marginal value per step.
Strategically, the business effects show up as fewer revision cycles and higher trust. Biotech CI reports with early safety signal integration, procurement landscapes that harmonize conflicting PDFs, and compliance updates that allocate extra steps to new rules. Adoption playbook: pilot on one high-impact report, enforce provenance, tier compute by decision risk, and template the plan and judge rubric by domain to scale repeatably.
In regulated and emerging market contexts, the agent's audit trail, every question, answer, and revision becomes your evidence ledger. Go offline first with local corpora and translation-aware retrieval. Lean on early exits when bandwidth is tight, and watch second-order effects. Documentation quality becomes a growth lever. Regulators start asking for trajectories, and talent levels rise as junior analysts use the draft scaffold to deliver senior-grade structure.
Highlights and key innovations, then. Draft as controller with retrieval-guided denoising, component-wise self-evolution with critique and merge, structured answer storage for provenance, novelty gating to avoid redundant steps, calibrated side-by-side evaluation to keep us honest, and compute-to-risk scheduling to make this economical. Or to borrow a line, in God we trust, everyone else bring diversified evaluators. And let the evolving draft be your GPS that recalculates routes as evidence changes.
Final insight. This loop doesn't just boost accuracy, it combats narrative drift by rebalancing the whole story when a single critical fact updates, which is exactly what fast-moving domains need.
Monday morning move. Pick one pivotal report. Run a draft-centric agent alongside your current process. Track coverage, novelty, and stability. And make a decision on tiered rollout based on fewer rework cycles and clearer executive alignment. That's the end-to-end picture. Drafts that think, retrieval that grounds, evaluation that aligns, and orchestration that scales. Thanks for joining us on AI, and until next time, stay curious and keep iterating. If a specific insight resonated, send this podcast to a teammate and compare takeaways. Shared reflection compounds value.